22, the floor of a ballroom has an area of 600 square meters. So don't think it tells us if it's a rectangle or a square or anything, but I'll just draw it like this. So the area is 600 square meters. An architect creates a scale model of the floor of the ballroom where the length of each side of the model is 1/10 the times the length of the corresponding side of the actual floor. What is the area in square meters of the square model? The danger here, again, this would be towards the end of a module. You would know this would be a hard question, so be very skeptical about an answer that comes just too quickly, too easily, right? Because you might say, oh, okay, well, if the scale model, if the sides are 1/10 the sides of the real thing, then the area must be 1/10, right? And if I take 1/10 of 600, I get choice C. Very tempting, but unfortunately for us, wrong. Again, we have to take it slow, right? Let's be careful here. Let's not rush. Let's just do the work appropriately, and we'll get it right. We won't lose the point. So a lot of options here. What I would recommend is let's pick some dimensions for our original ballroom. As long as they multiply to 600, we're good. Let's apply the 1/10 rule to those sides to find the lengths of the scale model sides, and then we'll calculate the area of the scale model, and we're good. So let's do 60 and 10 here. I think that seems reasonable, right? 60 times 10 is 600. And that will make the next step a little bit easier when we calculate the dimensions of our scale model, right? So each of the scale model sides is 1/10 the side of the real thing. So 1/10 of 60, 60 times 1/10 is 6. 10 times 1/10 is 1. So if I find the new area of this model, it's going to be 6 square meters, I guess. That's a really big model, but anyway, no worries. 6 square meters, and that gets us choice A. So that's one option. You can pick numbers. Now you might say, well, it feels a little weird that I can just pick any numbers as long as they multiply to 600. And you can, it works. But you might like some proof, or you might like another way to do this. And here's how we can do that. So let's take our area, and let's, instead of assigning a length and a width to this rectangle, let's just call it L times W, right? We don't know the L, we don't know the W. But we do know the product of LW is 600. So bookmark that for a minute. Let's go to our scale model, and let's think about what would be the side lengths of our scale model in this case. Well, it's 1/10 the length and 1/10 the width. So 1/10 length, 1/10 width. Now, what would be the area of this given these dimensions of 1/10 length, 1/10 width? Well, let's multiply them, right? The area is going to be 1/10 length, that's our length, times 1/10 width. And cleaning this up, we're going to get 1/100th LW. But wait a minute. We can make a substitution. We know that LW is 600. So this has just got to be 1/100th of 600, and that's just 6. This kind of proves why, as long as you pick the right L and W to multiply to 600, it's going to always work, because whatever that product is, it's always going to be 600, and you're always going to end up taking 1/100th of it. And so this all leads us to choice A. I said at the beginning of the video that be very careful on a hard question like this. If you solve it in 5 seconds, just be skeptical, double check your work. There is kind of a way, though, to solve it quickly now that you've gone through this process. And that is to recognize that the ratio of the areas of two figures is the square of two similar figures is the square of the ratio of their sides. So now that we know the ratio of the sides is 1/10, the ratio of the areas would be the square of that. And if I square 1/10, we get 1/100th. And so this tells us the ratio of the areas is 1 to 100. And so if the big guy is 600, we scale that down by a factor of 100, we get 6. So there is a fast way to do it. But frankly, if I'm doing this test, I'm just never going to trust that I'm not going to make a mistake. It's just, I'd rather be careful, do the work, maybe do it a second way, just double check. Does it make sense with that quick way? Like if I do it the long way and I get an answer, and it also kind of makes sense with the shortcut, I just feel very comfortable that I've gotten this one right. So trying to triangulate your answer, get it from multiple ways, you just know that you're more likely to have it right versus doing it one way that's maybe a little brittle, a little fragile. But yeah, all roads here lead to choice A.